What's up mga kachimek? So, Sir Jello here once again. For this session, we are going to talk about carbon compounds. And for this particular topic, we are just to talk about first the origin of carbon. Where did the carbon came from? Where did it originated? And then some special properties of carbon. Why is it so important to talk about carbon? Why did organic chemistry came into the picture? And then we'll talk about hydrocarbons, specifically alkanes muna, since this is the least complex of all hydrocarbons. And also, this will serve as a foundation to understand alkenes and alkynes easier. And then we'll talk about a little about the different kind of structures that we are going to use as we proceed with organic chemistry. So are you ready mga kachimek? Let's go, let's go, let's go! Without further ado, I want you to watch out for some keywords that is important in understanding organic chemistry, specifically carbon compounds. So we'll be talking about organic chemistry, hydrocarbons, alkanes, expanded, condensed, and skeletal. So watch out as we talk about these things. Alright, to begin, the very question is, where did carbon came from? So I know you're thinking, your brain thought this is a Sharingan by Kakashi or Madara. No, it's not a Sharingan. It's just an animated version, an eye-catcher version of a carbon. So here is your nucleus. I don't know why my markers are not working. Okay. Here's your nucleus inside with 6 electrons around it. Alright? So that's 1, 2 in the inner or in the first energy level, and then another 4 on the second energy level. But the very question is, why is it not skipping? Alright. Where did carbon came from? Along with the different elements. So we all know that the first element is hydrogen with 1 proton and 1 electron. Helium with 2 proton and 2 electron. We also have lithium with 3 electrons and 3 protons. So 3 protons and 3 electrons as well. It's not loading. We have beryllium. The lithium seems to be missing in action. So the beryllium has 4 protons and 4 electrons, to be followed by boron, our 5th element with 5 electrons and 5 protons as well. And finally, our 6th element, again, the carbon. But again, where did carbon came from, along with these different elements that we have in the periodic table? So if you can remember your Earth Science, if I'm not mistaken, or Earth and Life, or your topic in the very first topic, if I'm not mistaken, in Earth Science is the origin of the universe. And I'd like to use that approach to introduce carbon. Usually when I teach astronomy, I start with the macroscopic level, or even Earth Science. Macroscopic, meaning from the universe going to the Earth, so that we can understand the similarities and differences that happens in the universe and in our planet. So, in the beginning, if according to the Big Bang, if the Big Bang is true, that's the most acceptable theory as of now, there was only one element, or the very first element, which is the hydrogen. After the Big Bang, there were protons and electrons going around. A proton captures an electron, and there you have it. A first neutral item in the universe. We call element, the hydrogen. And then, for billions of years, I'm not sure with the date, probably after 4 millions or 4 million years, napuno ang universe ng hydrogen. There were an enormous amount of hydrogen in the universe. And eventually, nagsiksikan ang mga hydrogen sa universe, because almost all protons captured one partner, the electron. Sana all. And then, eventually, this clustering of hydrogen give birth to another thing in the universe. That's what we call star. A star, maybe you know already, no, hindi siya yung may mga edges. No, it's a sphere, no, it's a ball, an oval, if you may. No, it's a spherical object, no, not a perfect sphere, no, but it's a round sphere. It's a spherical object that is composed mostly of hydrogen gas. No, at first, no, when it's being born or being created, it's all hydrogen gas. So basically, a star, you can say, is just a ball of hydrogen gas. So what is happening inside the star? So after hydrogen, nabuo yung mga stars, no, and a lot of stars was born. And here, no, since nagsisiksikan ang mga hydrogen, no, the tendency of this one is to either hit, no, after hitting, they have two options, either to hit and bounce or to hit and combine. No, that's a thing in physics we call nuclear fusion or nuclear fission. So what is happening inside the star, no, during the early times in the universe is the nuclear fusion, where a proton, instead of being repelled by the other proton, no, they combine, no, and eventually, since we already have two protons, the electrons should be two as well, no, for us to have a neutral charge, and this give birth to our second element, no, the helium. So again, from hydrogen clumping inside a ball of gas of hydrogen, nagsama-sama si proton, electron. There you have it, the second element, which is the helium. And that's the reason why, just a trivia, no, the sun, sabi nga nila, will eventually die. Why is that? At first, it was just pure hydrogen. And then, because of these collisions and nuclear fusion inside, no, the helium are being born, and they are being burned. Now, this is the gas of the stars. It's the reason why they give heat, no? So the helium is being consumed. So basically, the sun is consuming itself as well as the rest of the stars. And then, the nuclear fusion continues until we build the third element, lithium, the fourth element, beryllium, and so on and so forth. So basically, no, carbon is a product built, no, many years ago inside a star. So, yan, maybe you have heard of the statement that carbon is the element of life. Why is that? Because the all organic compounds, no, are made up of carbon. And the first thing we look for when we go to a place like halimbawa, a dead swamp, we look for carbon. No, because without carbon, life will not be possible because it's the foundation of life nga, as we call it. If we go to Mars or to the moon, no, the scientists only look for carbon because the carbon compounds are essential for life to exist. So carbon, basically, which was created inside the star billions of years ago, no, are the reason why we are here in the earth. Why Sir Jello is talking and why you are watching my video, no, my boring videos, or why are you studying, or why are you enjoying your life. It's because of carbon. So if somebody told you that you are made up of a star, or you are made up of star particles, that's not just figuratively true, no, that's not just based on literary pieces or artwork. No, that's scientifically true because all the carbon compounds in your body, specifically the carbon, were made, no, billions of years ago. So it gives us questions about philosophy na, is age, or does age really matter, or are we of the same age because we were born, no, in the same time as the universe, things like that. But let's not talk about it, no, because it's not part of our topic. But yeah, my point here is carbon is so amazing, no, so as the universe. So yan, for many years, no, specifically 200 years ago, people believe this, no, that the carbon can only be found in organic or in life, no, in living things like plants and animals until uh, Frederick Wohler came into the picture. No, he's a scientist who was able to synthesize ammonium cyanide, no, an inorganic compound to form urea. No, in short, though I don't want you to dwell with this, no, because we'll discuss it on the later part. Uh, si Frederick Wohler, from an inorganic thing, no, this ammonium cyanide, he created organic compound. And then the chemistry world, no, was shocked. Hindi lang pala sa living things pwede magkaroon ng carbon compounds. Even in inorganic compounds, we can find, no, carbon compounds. And this give birth to organic chemistry, no? Later on, no, on our discussion, we will discuss this process. But because of this, no, the organic chemistry was born, no, because of Frederick Wohler. And then they further study the special nature of carbon. And because of their study, no, I'll be summarizing the special nature of carbon for you. The first characteristic of carbon, why is it so special, is that its electron configuration is 1s2, 2s2, and 2p2. And what does it tells us, no? Ano naman kung ganyan, sir, ang electron configuration niya? Well, it tells us that it has two energy levels. And at the second energy level, you have 4 electrons, which means it lies in the 14th group, no, if you'll use this standard groupings, or if you'll use our nasanay natin, that's 1, 2, 3, 4, no, fourth group. If you remember when we were discussing about ionic compounds, no, I keep on avoiding this line, no, sinasabi ko lang group 1 is +1, group 2 is +2, group 3 is +3, si carbon is snub muna natin. Dito naman 3 negative, 2 negative, and 1 negative. Stable si noble gas, snub muna natin si carbon. The reason is carbon, silicon, along with this until Fl, no, these elements are very special, specifically the carbon, because the question here is, will they give 4 electrons or will they receive 4 electrons? So they are stuck between being the receiver or being the giver, no? And I don't know, the universe is so amazing that even the elements compromise. Instead of giving and sharing, they decided, no, to complete their octet, no? You remember, elements needs 8 valence electrons to be stable. No, they don't want to form ions, but rather they share electrons. And that's why we have covalent bonding, if you can remember our last topic before midterms. So instead of giving, you know, they'd rather share. An element can attach to a carbon, pwedeng dalawa, pwedeng tatlo, pwedeng apat. No, that's why a carbon is very special. Also, it can readily form bond with atoms of other elements like oxygen, hydrogen, and halogens, no? Or the group 7. So, madaming pwedeng kumabit kay carbon. Meaning, because of this different, pwedeng puro oxygen, pwedeng puro hydrogen, pwedeng nitrogen, pwedeng fluorine, chlorine, etc., etc., or pwedeng a mixture of them, no? It gives birth to several compounds. And remember, no, an element is unique already, but when it can compose or it can produce another substance through sharing or giving of electrons or receiving, no, it's very valuable. And note that carbon shares electron, so, and it can readily form not just oxygen, hydrogen, and nitrogen and the halogens with other carbon as well, no, with single, double, or triple bond. So imagine the flexibility of carbon. That's the point. It can have, because of carbon, no, we have a lot of compounds that are very useful in our everyday living. No, name it: food, drugs, transportation, infrastructure, etc., etc. So carbon is very important. And finally, no, one interesting nature of carbon is the allotropes, no, or what we call the allotrope. So what is an allotrope? So maybe you have watched this in some amazing Facebook videos or maybe some documentaries, or if not, you know, would you believe if I tell you that the graphite in a pencil, the soot in or in the in our kitchen materials, no, that we're using, yung uling, yung anong tawag niya, agyuiw, and the diamonds, no, they are all the same? Probably you won't believe me because they're technically different. But scientifically saying, they are very, very the same. The same is not a right word. No, it's very, very similar. No, so these are what we call allotropes. These three are made up of carbon. No, however, they differ in the structure and formation. So a graphite, no, in a microscopic level, will look like this, no, a spider web, and a diamond would look like a pyramid, no, or a house. So ito yung structure niya. While yan, while the soot is similar to the graphite. So the allotropes or the allotropy is the existence of chemical element in two or more forms. No, they differ only in the arrangement of atoms. So how they are positioned and how they are arranged in a certain item, a certain thing. Now, what is very interesting here, what some scientists uh, uh, are very interested before is that what if I can create, because diamonds are created in nature, 'di ba? That's why it's very expensive because to form a diamond you'll need to wait. Oh, you'll need to wait probably hundreds of years, thousands or even millions, no, to completely for our environment, for the nature to completely create a diamond. So a wise scientist thought, what if I can rearrange, no, through laboratory the graphite, no, i-rearrange ko lang siya since they are made of the same compound to create a diamond. Pwede ba 'yon? Pwede, 'di ba? Question, nagawa na ba ng mga scientist or may nakagawa na ba? If you answered no, then you're correct. Because kung meron na nakagawa nito, diamond would lose its value kasi madami ng production, no? However, they are finding it difficult to create diamond out of graphite. But nonetheless, no, their attempts did not went wrong, or I mean did not go to waste because they created other allotropes, meaning the same components but different in arrangement, like BC8, no, fullerene, nanotube, no, in our devices, and graphene. And you can search them if you are very interested. But the point we're making here is that carbon is very special. That because of its flexibility and it can be rearranged, no, through different angles and molecular geometry, we can create several products that have different use and different appearances, different descriptions, etc., etc. So, I don't know if the scientists already gave up creating diamond out of graphite, but who knows? No, maybe if you decided to become a chemical engineer and nag-focus ka sa organic chem and you decided to get rich, maybe you want to try this one. No? It's difficult, yes, but it's not impossible. And then give me a diamond once you did it. Charot. Anyways, so because of these special properties of carbon, no, it can form millions of different compounds. Imagine, no, the word millions. One compound, like say for instance, a methane, no, it's already very important. Carbon dioxide, no, they have a different property. Carbon monoxide, etc., etc. No, imagine talking about millions of carbon compound. Now, this is very amazing, no? Because before we are always focusing on inorganic compounds, inorganic chemistry, where we have 100,000 compounds lang. Dito meron tayong 20 million organic compounds. What do you think would be the problem here? No? Or what do you think the scientists realize because of this uh, discovery that 20 million, 20 ano pa ata itong ano eh, itong site na kinunan ko, 2015, 2018. So probably they discovered already 40, 50 million of organic compounds. So what do you think would be the problem here of this fact? Very good, no? If you think how to name, no, these 20 million organic compounds. So that's the first thing in organic chemistry, no? We are to name the different organic compounds. And imagine if you will give them random names and you have to memorize millions of random names. So, all thanks to UPAC, no, the International Union of Pure and Applied Chemists, they gave us a guide or the nomenclature in naming organic compounds, specifically alkanes, alkenes, and alkynes first. Our hydrocarbons. Again, organic compounds are compounds which are made up of carbon. So, technically, kapag may carbon, automatically organic compound siya. No? And then, the very basic organic compounds are the hydrocarbons. Now, by the name itself, no, it is very easy to remember. Hydrocarbons are compounds that are made up of no other element except hydrogen and then carbon. So, we only have hydrogen and carbon. So, no matter how many hydrogen or no matter how many carbon, basta H and C lang ang nandyan, that's automatic a hydrocarbon. So, it's a major group of organic compound because we can create a lot of hydrocarbons. And then, yan, it is divided into aliphatic and aromatic, meaning with the smell, and a benzene ring. No? There's a circular form. So, we'll focus first on the aliphatic hydrocarbons. So, let's start with the basic hydrocarbon, the alkane. Because this, again, as I mentioned in the objective, this is the least complex of all. And then, once we've mastered alkanes, the rules, don't worry, basic pa lang naman tayo, alkenes, alkynes, and the rest would be very, very easy. So, trust me. So, we have to pay attention for the alkanes. So, let's start. To define alkane, so alkane is a hydrocarbon, meaning, again, it's made up of only hydrogen and carbon. And it has a general formula, sorry, medyo malabo, which is CN H2N plus 2. So, H2N plus 2. What does this mean? No? Where N is 1, 2, 3, etc., etc. So, if I have 4 carbon, or sabihin natin muna 2 carbon, if I have 2 carbon, that would be C2. Therefore, my hydrogen would be 2 times 2 plus 4. To indicate how many hydrogens should attach to my carbon. So, remember this formula. This will give me C2 H4 plus 4. So, C2 H8. So, if I have 2 carbon in an alkane, I should have 8 hydrogens attached to it. Later on, we'll understand the reason behind this one. Also, alkanes only have a single bond. So, they only have one line, no, that connects them. And then, these are called saturated hydrocarbons. Why is that? Because, as I've said earlier, a carbon can share 4 electrons. No, it's 4 valence electrons. So, meaning 4 other elements, be it carbon, halogens, etc., etc., or hydrogen. So, since we are talking about hydrocarbon, it can accommodate, no, 3 hydrogens, 1 carbon, 2 hydrogens, 2 carbon, or 4 hydrogens because of the single bond. So, we call it saturated hydrocarbons. Alright? So, hopefully, na-get yun. So, yan. In naming hydrocarbons, parang may nawala ang slide. Naman. So, in naming hydrocarbons, we use prefixes. So, pay attention now. We base it in the number of atoms, or the number of carbons, to be exact. So if there is only one carbon, so we only have one carbon, so we use the word meth. So meth for one carbon. So meth has one carbon, therefore it can have 4 hydrogens around it. And since it's an alkane, no, it becomes methane. So this is our very basic hydrocarbon, the methane. We've encountered this a lot of times. And the reason it's methane because in from the alkane, meaning single bond saturated, meth, that's the prefix for one carbon, meth. Alright? And then, bakit kaya ang meth? No? Si carbon, natagpuan niya si hydrogen. 'Di ba? Oh. Carbon, meth, H. Hydrogen. Charot lang. Invento ko lang 'yan. So, methane, that's the prefix. Meth is the prefix for 1. Baka naniniwala kayo sa mga gawa-gawa ko. For 2 naman, we have eth. So, that would give you. So, let's check what would the ethane looks like. So, eth would look like this one kasi may dalawang carbon. So, we have to place 1 carbon. So, eto na. Ilang hydrogen ang kayang kumabit kay carbon? Kumabit. Or ma-attach kay carbon? We will only have 3. Why is that? Because the other supposedly slot for another hydrogen was connected to carbon. So, dito sa other carbon, 3 na rin. So, we cannot have another hydrogen in this part because the carbon are utilizing their valence electron. They're sharing 1 valence electron. So, eto, ang methane, the formula of methane would be C1. So, kahit wala ng 1, as usual. So, this becomes CH4. Let's see if it agrees with our formula, CnH2n plus 2. Sige. Ayan, naglalag na ang converge. Wag na muna ngayon. So, tingnan natin. C1, H2 times 1 plus 2. Tama. C1, H4. So, that's your methane. How about your ethane? Yung pangalawa mong alkane. So, F for 2. So, wala tayong entry dyan. So, we have 2 carbons. So, C2, H2 times 2 plus 2. So, 2 times 2, 4 plus 2, 6. So, mali pala yung kanina. Naging 8. Naging 8 yung sagot ko. Balikan nga natin. Sorry, baka ngayon ko lang na-realize. Tinawanan nyo ako dito. So, 2 times 2, 4, plus 2 pala kasi ito dapat. So, 6 lang. So, very good sa mga nag-correct sa akin. Pero hindi nyo masabi kasi nasa video pa. So, dapat, C2, H2, 4 plus 6. So, we have 1, 2, 3, 4, 5, 6. Tama. All single bonds, 2 carbon, 6 hydrogens. That's your ethane. And then, prop. No? Bakit 3? Bakit prop? Hindi pala, kala ko 4. Kasi kung 4, dapat sa 4 na lang to na binaliktad lang, pro. Charot. Prop is for propane, no, with 3 carbons. And this will be the structure for propane. 1, 2, 3, C3H8 because of the formula. Excuse me, that's 1, 2, 3, 4, 5, 6, 7, 8, and 3 carbons. Butane for 4, C4H10, that's 1, 2, 3, 4. Yan, the butane and the beast. Charot lang. So that's your 4 first alkanes. Now, methane, ethane, propane, butane. 1 carbon, 2 carbon, 3 carbon, 4 carbon. Now, for the rest of the time, I want you to complete this table, no, until dec, no, our decane. So, nonane, octane, heptane, hexane. So, write the formula, no, mali ang nakasulat dito. It's not the prefix, it's the formula, and then write the number of atoms or the skeletal formation or the structure of the different alkanes. Now, starting, you may now start with the fifth, the pent. So, pentane. Yan. Alright. So, you may do it and pause the video for a while, or you may continue watching this video and then do it later on. So, now, I'll teach you the simpler way in writing this one. No? So, the scientists, they are very, very, very lazy. Or maybe they just need other time to do some things. Maybe attend to their family and other needs. No? So, they created something simpler than this one. So, this is how you draw the structural formula. So, halimbawa, let's use ethane for example. So, that would be this one. So, this is what we call the expanded structural formula. So, to save time, kasi sabi nga natin, we have 20 millions. And the alkanes, I forgot to tell you, does not end in decane. No? So, pwede pang maging undecane, dodecane, tapos tridecane, etc., etc. No? The list continues as long as you want to add carbon in your compound. So, kung papasulatin sa'yo yung 40 carbons, kaya mo ba? Kaya, pero it will take too much time. So, from the expanded, so this one is your expanded, they decided to create a condensed one. So, meaning, isulat ko na lang yung carbon, so ethane, tapos, lagyan ko na lang ng ganito. Di ko na lagyan ng hydrogen. No? Kasi, alam ko naman na I'm talking about hydrocarbons. So, automatic, other scientists will know that I'm talking about ethane. No? 2 carbons with 6 hydrogens attached to it. No? So, mas madali. I can do it easier as compared to the expanded. But, another wise scientist realized, okay, pwede naman pala to. So, what if I create a much simpler way of writing the structural formula? So, halimbawa, dot na lang, tapos, lalagyan ko ng linya. So, this is my carbon, this is my dot, this is my dot. And, this will be my hydrogens. Charan! So, mas madali. Di na ako magsusulat ng carbon. Dot na lang. So, meron mas creative na scientist, sabi niya, okay. Magandang idea. So, ethane, ganito na lang. Dot. Since lahat naman tayo matalino, pag ginanto ko, this is carbon, and kahit hindi ko nalagyan ng linya, even I don't place a line, you'll know that there should be 3 hydrogens attached to it. So, mas madali, pero it requires a bit of thinking. Or automatic dapat yung concept na, I know, 3 hydrogens here, 3 hydrogens here. So, mas madali. I can write 20 of this easily. 20 dots, 20 carbons, as compared to doing this one. But, they found a problem here. Minsan, madali. Alam mo, kinontinue mo to, sometimes, maliit yung dot, they fail to notice it. They thought it's just a broken line. So, this was not that good. So, another scientist, a lazy yet a creative one, created a stuff. For ethane, sabi niya, I'll just create one line. A line. It could be a straight line, a slanting line, a horizontal line. But, if I would add another carbon, the next line, so let me rewrite it. So, ito ang aking ethane. Sige, medyo pangit pa rin. Ito na, ethane, ito. Meaning, I have 1 carbon here, 1 carbon, and 3 hydrogens. So, the dot are not visible. Sabi nila, paano yan? Hindi nakikita yung dot. Don't worry, because if it becomes a propane, I'll be adding another line in an opposite direction, like a zigzag, or in the opposite way. If this is a slanting to the right, this slants going down, a slant up, slant down. So, meaning I have 1 carbon here, 1 carbon here, 1 carbon here. And here, I know there's 2 hydrogen that should be attached or can be attached. Dito naman, merong tatlo. Hopefully, you can follow. Merong tatlo. Nagigets? So, ganito lang naman siya. Carbon, 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 tatlo. Tapos may nakakabit na dalawang hydrogen. Hydrogen, hydrogen. So, medyo mahaba. No, hydrogen. So, same goes here. No, but if I know already this concept that a carbon should hold 4, no, and if it's attached to another carbon, it can only accommodate 3. If it's attached to 2 carbon, it can accommodate 2. No, I know just by looking here that the carbon here on the edge, no, though without a dot, no, has 3 hydrogen. Dito merong dalawa. This makes my life easier. So I can continue writing like this one. And probably this looks familiar to you. This way of writing. This is our skeletal structure. And we'll be using this for the rest of our discussion on alkanes. With attachments, with rings, and then through alkenes and alkynes. So, hopefully you understand. And to check comprehension, as I was asking for your task, you have to continue doing this is the prefix, not the prefix, the molecular formula. So, just may write MF. Don't think of any other meaning for MF. That's molecular formula. And the number of atoms, in the condensed form, the expanded form pala. Expanded form. And then, also, add another table, make a condensed and skeletal version of your output. So, the condensed form, as I've said, is this one. Walang hydrogen, mga lines lang. And then the skeletal looks like this one. Alright? So, there you have it. That's it for today. And, yan. Next meeting, we'll talk about what if there are attachments for these alkanes. Thank you so much, mga kachimek. Peace out. And if you have questions, again, you may email me at my email.